Unit 3, Advanced DevOps. Good morning, everyone. Think about the apps you use every day: Instagram, Spotify, or Netflix. They update constantly, sometimes multiple times a day, without ever going offline. How do they do it? The answer isn't just DevOps, it's advanced DevOps. Today, we are moving beyond basic coding to look at the engine room of modern software, systems that fix themselves, scale automatically, and treat infrastructure like code. Welcome to Unit 3. In this unit, we will explore the technical magic behind those seamless updates. We'll break our study into 5 pillars: automatic rollback, clustering, automatic provisioning, infrastructure as code, and scalability. Then we will look at how to build these using cloud services and Jenkins. These 5 concepts, rollback, clustering, provisioning, IAC, and scalability, are what differentiate a startup project from a global enterprise system. They ensure that the software is not just functional but resilient. The first rule of advanced DevOps: the system must get back into a working state as fast as possible. Downtime is expensive, so recovery speed is our primary metric for success. The foundation of this recovery is the deployment pipeline. It allows us to move code through build, test, and deploy stages in a predictable way. Consistency is key here. If the process is the same every time, finding errors becomes much easier. In the past, if a release failed, a human had to watch a dashboard and manually revert the code. This is slow, stressful, and prone to mistakes, especially if an error occurs in the middle of the night. The solution: automated rollback. Advanced DevOps tools now monitor the health of the app for us. If they see a failure, they automatically trigger a rollback to the last stable version. We also use feature toggles to turn off a specific broken part of the app without crashing the whole system. Looking at these diagrams, you can see how the monitor phase feeds directly back into the deploy phase. This closed loop system ensures the environment stays healthy without human intervention. Introduction to clustering. Next is clustering. A cluster is a group of servers communicating together. This ensures that even if one server catches fire, your application stays online because the other servers in the cluster pick up the slack. Master and worker nodes. Think of a cluster as a team. The master node is the manager that coordinates tasks, and the worker nodes are the team members doing the actual work. This hierarchy keeps the system organized. To manage these complex groups, we use tools like Docker and Kubernetes. They automate the process of moving containers to the servers that have the most free memory or CPU power. What is Docker? Docker is the industry standard for containerization. It packages code, libraries, and settings into one container. This eliminates the old excuse: "But it worked on my machine." Benefits of Docker. Docker gives us speed, isolation, and security. It allows developers to build once and run anywhere, from their laptop to the public cloud. In these images, you can see how Docker creates a layer of abstraction. It doesn't matter what operating system is underneath, the Docker container stays the same. While Docker builds the containers, Kubernetes manages them. It is an open source platform designed to handle the life cycle of thousands of containers at once. As shown here, Kubernetes handles the networking and storage. It ensures that if a container crashes, a new one is started automatically. It is essentially the brain of the data center. In advanced DevOps, we don't wait for IT to set up a server. We use automatic provisioning. The infrastructure is created on demand exactly when the code needs it. To do this, we need 3 things: a cloud environment, monitoring tools to detect demand, and automation scripts to build the resources. This slide shows the full cycle. When a developer pushes a code, the environment is provisioned, the code is tested, and it's deployed, all in one smooth, automated motion. Scalability factors. Scalability is the system's ability to grow. We have to consider not just CPU power, but also network bandwidth and storage capacity as our user base expands. The cost of scalability. A warning for you: cloud scaling is easy, but it's not free. Part of a DevOps engineer's job is to ensure the system scales down when it's not needed to save on licensing and usage fees. Defining IAC infrastructure as code means we treat our hardware like software. We write a script to define our servers, networks, and databases. This makes our entire infrastructure repeatable and version controlled. Practical IAC, for example, a developer can use a Docker file to define their own storage volume. This removes the bottleneck of waiting for an operations team to manually configure hardware.
We conclude our deep dive into these 4 core pillars. We need to understand that the goal of Unit 3 is resilience. We aren't just trying to ship code faster. We are trying to create an environment where the system can survive errors, surges in traffic, and hardware failures without any human intervention. We are going to recap how automatic rollback, clustering, provisioning, and infrastructure as code work together to create a self-healing digital world. Advanced Devops changes this by making the system self-aware. We integrate monitoring directly into the deployment pipeline. If the error rate spikes or the server response time slows down immediately after a deployment, the system initiates an automatic rollback. It essentially undoes the update before the users even notice a problem. We also use feature toggles. Think of these as remote control switches. We can deploy a new feature, but keep it off for most users. If it fails for the small group testing it, we simply toggle it off without needing to redeploy any code. This creates a closed-loop system where the monitor phase and the deploy phase are constantly talking to each other to ensure safety. But where does this code actually live? That brings us to our second pillar, clustering. No modern application runs on a single server. A cluster is a group of interconnected servers working together so that if one server catches fire, the others automatically pick up the load. This is what we call high availability. To manage this, we use a master and worker architecture. The master node is the brain. It decides which server has the free space to handle a new task. The worker nodes are the muscles doing the processing. But to make this work, the software must be portable. This is why we use Docker. Docker packages your code into a container, a standardized box that includes all the libraries and settings needed to run. When you have thousands of these containers, you need a conductor for the orchestra, and that is Kubernetes. Kubernetes automates the life cycle of these containers, starting them, stopping them, and fixing them. It is the intelligence that allows a massive data center to behave like a single, reliable machine. Once we have our cluster, we need it to be flexible. This is our third pillar, automatic provisioning and scalability. In the old days, getting a new server took weeks. In the DevOps world, we automate the environment itself. When our code needs a testing environment, it uses a script to spawn one in the cloud instantly. This automation is the secret behind scalability. Scalability is the system's ability to breathe. If your app goes viral, your infrastructure must expand, adding more servers automatically. This is horizontal scaling. However, as future engineers, you must remember that the cloud isn't free. Cloud providers charge by the second. A sophisticated pipeline doesn't just scale up, it scales down during quiet hours to save money. We are always balancing maximum performance with maximum cost efficiency. Finally, we have the most transformative concept, infrastructure as code, or IAC. Traditionally, setting up a server involved a human clicking through menus and checking boxes. This is impossible to repeat perfectly every time. With IAC, we write a script that defines our hardware. If we need a database, a firewall, and 3 web servers, we write it in a text file. This file is version controlled just like our app code. This means we can recreate an entire data center in minutes just by running a script. This empowers the developer. You no longer wait for a server admin to give you resources. You define them yourself. This removes the bottleneck of manual operations and ensures that your production environment is an exact twin of your testing environment. By mastering these 4 pillars, automatic rollback, clustering, provisioning, and IAC, you are moving from being just a programmer to being a system architect. You aren't just writing code, you're building a resilient, self-sustaining ecosystem. These are the tools that allow the apps we love to stay online, no matter what. Thank you for your time today, and let's carry these concepts forward into our practical implementation. Now let's look at the CI/CD pipeline, the automated assembly line that brings all these concepts together. When we use the cloud, we get the benefit of speed and integrated monitoring. Platforms like IBM and Oracle Cloud provide the tools to make this happen seamlessly. Continuous integration CI is about finding bugs early by merging code daily. Continuous deployment CD is about getting that bug-free code to the customer automatically. Every pipeline has 4 stages: source getting the code, build compiling, test checking for errors, and deploy going live. We use GitHub for our source, Jenkins to build the artifacts, and tools like Selenium to run automated tests. If any stage fails, the process stops and alerts the developer. Finally, here is how you build a pipeline in Jenkins in 6 steps. Log in and select New Item. Name it and choose Pipeline. Configure your script. Click Build Now. Review the console output for errors. Use the Pipeline Timeline plugin to visualize the flow. Everyone is talking about advanced Devops. Shall I tell a small story? Imagine a huge mobile game is launching. Let's call it Telepathy Quest. Millions of 2K kids are waiting to download it at 12 a.m. The developer is a 90s kid who does everything manually. It becomes 12:01 a.m. The server crashes. Why? Because he didn't expect so much traffic. He's panicking, typing code, sweating. The server busy message is everywhere. Twitter la trend aguthu #gameflop. But on the other side, there is a 2K kid engineer. He is chill. He is eating popcorn and watching the launch. People ask him, "The load increased, aren't you scared?" He says, "No need to fear, Nanba. I used advanced Devops." 1. Clustering. He didn't use one server. He used a squad. If one server gets knocked out, the rest of the squad revives it and keeps the game running. 2. Scalability. When 1 million kids logged in, his system leveled up automatically. More players came in, so more servers spawned instantly. 3. Automatic provisioning. He didn't wait to buy hardware. He wrote a script that says, if traffic hits 100%, create 10 more servers now. 4. Automatic rollback. At 12:05 a.m., a small bug appeared in the skin store. Did the game crash? No. The system detected the error and rolled back to the previous stable version in 2 seconds. Like a respawn in a game. Moral of the story? In life, problems will come like a final boss. If you try to fight them manually, you will get game over. But if you build a system, an advanced DevOps system, you can automate your wins. Instead of hard work, go for a smart work Nanba. Don't be the developer who panics. Be the engineer who respawns automatically. Design your life like infrastructure